So in this video, let us look at the topic of polar coordinates. So you know what Cartesian coordinates are, right? Cartesian coordinates. So if you take the Cartesian coordinate system, any point P on this Cartesian coordinate system can be represented by two numbers x and y, x coordinate and the y coordinate, where x coordinate is the distance from y axis, this is the x coordinate, and y coordinate is the distance from x axis, this is the y coordinate. X coordinate is the distance from y axis, y coordinate is the distance from x axis. So if you know these two numbers, you can locate the point. So now polar coordinates gives you another way in which you can locate the point. So in the polar coordinates, what you give is not x and y coordinates, you give the coordinates r, theta, where r is the distance of the point from the origin. So I give you this distance, and theta is the angle made by this ray with x-axis. So if I give you these two numbers also, you can locate the point. For example, if I give 1, pi by 3. So if I give you 1, pi by 3, that is, the point is at a distance of 1 from the center, 1 from the origin. That is, the point might lie somewhere on the unit circle. And the ray joining the origin with the point is making an angle of pi by 3 with x-axis. That is, the point has to lie on this ray, making an angle of 60 degrees with x-axis, right? Now the point has to be at a distance of 1, that means the point has to lie on this circle. The ray has to make pi by 3 with x-axis. That is, the point has to lie on this ray also. Hence, this will be the required point. So can you see that I get a fixed point corresponding to an r and a theta. And correspond to every point P, you have 1 r and 1 theta. So every point can be uniquely mapped with the coordinates which are called polar coordinates. So now the problem here is, so if I give the Cartesian coordinates of a point and the polar coordinates of a point, so can you interconvert them? That is, if I give the Cartesian coordinates, can you convert them into polar coordinates? If I give you the polar coordinates, can you convert them into Cartesian coordinates? For example, I have given you 1, pi by 3. So this point is 1, pi by 3 in polar coordinates. So can you convert this into Cartesian coordinates? That's the question. That's what you'll be required to understand. So I think this is a very easy question, because so 1, pi by 3 means this length is 1 and this angle is pi by 3. So now if I want the Cartesian coordinates of this point, I need to find the distance of this point from x-axis and the distance of this point from y-axis. If I can find these two, then I can very easily find the x and y coordinates. So let this be the x coordinate, let this be the y coordinate. So by definition, cos pi by 3 is equal to x by 1, right? Adjacent side by hypotenuse. This implies x is equal to cos pi by 3 is 1 by 2. Similarly, if you want y coordinate, sin pi by 3 is y by 1. Sin pi by 3 is y by 1. This implies y is equal to root 3 by 2. Y is equal to root 3 by 2. So the Cartesian coordinates of this same point are x is equal to 1 by 2, y is equal to root 3 by 2. That means if the polar coordinates are known, the Cartesian coordinates can be found very easily. So can I extend this method to get a general formula? So if the polar coordinates of a point are r, theta, what are the corresponding Cartesian coordinates? So if this is r and if this is theta, obviously the x coordinate will be r cos theta, the y coordinate will be r sin theta from the definition of sin theta and cos theta. So Cartesian coordinates will be r cos theta, r sin theta. So cos theta and sin theta, if the point comes here, the signs of cos theta and sin theta take care of the signs of the Cartesian coordinates. You don't need to put them separately because r is always positive. Cos theta, if theta is in the second quadrant, cos theta will become negative automatically and sin theta will become positive automatically. So you don't need to specially put plus or minus again. So if r and theta are given, if you find r cos theta, you get the x coordinate. If you do r sin theta, you get the y coordinate. Next, if you are given the Cartesian coordinates, can you find the polar coordinates? So as you can see, r is nothing but the distance of this point from x-axis from the origin. So r is nothing but root of x square plus y square. And theta can be found out using trigonometry. Right? Theta can be found out using trigonometry. So depending on the sign of x and y, so if x and y lies in the first quadrant, theta will be acute. If x comma y lies in the second quadrant, that is x is negative and y is positive, theta will be in the second quadrant. X and y both are negative, theta in the third quadrant. X positive, y negative, theta in the fourth quadrant. And the allied position of theta can be found out using tan theta. So tan theta will be equal to modulus of y by x, mod y by mod x. So if you are given x and y, just do y by x and find the magnitude of it irrespective of sign. You get tan of theta, and this theta will be a allied position to the given position. And after that, depending on the signs, you can go to whatever quadrant you want. So this is how you convert Cartesian coordinates into polar coordinates and polar coordinates into Cartesian coordinates. So let us take an example. So let us look at the following examples. In the first two questions, you're given the polar coordinates of a point. You're asked to convert them into Cartesian coordinates. And in the third question, you're given the Cartesian coordinates and you're asked to convert them into polar coordinates. So now let us do one by one. So now you have r comma theta in the first question. So if you have r comma theta, the corresponding Cartesian coordinates are nothing but r cos theta and r sin theta. This 2 cos 2 pi by 3 and 2 sin 2 pi by 3. So you don't need to put any plus or minus extra. So this cos and sin take care of the signs by themselves. So that is equal to 2 times cos 2 pi by 3 is nothing but pi by 3 is 60 degrees, 2 pi by 3 is 120 degrees, comma 2 sin 120 degrees. So how do you find cos 120 and cos sin 120? We can use t of n pi by 2 plus or minus theta concept. So cos of 120 degrees can be written as 2 times 180 degrees minus 60 degrees, right? So this is equal to, so 2 times 180 minus something, you get an angle in the second quadrant, right? 2 times 90 degrees, right? 2 times 90 degrees is 180 minus 60 degrees is 120 degrees. So 2 times 90 minus something, you get an angle in the second quadrant. So cos is negative and the number is even. So cos becomes cos 60 degrees, that is equal to minus half. Similarly, if you want sin 120 degrees, so this can be written as sin of, again, 2 times 90 degrees minus 60 degrees, right? So again, the angle is in the second quadrant, so sin is positive. The number is even, so sin remains sin 60 degrees, which is equal to root 3 by 2. So cos 120 is minus 1 by 2. So 2 cos 120 is minus 1. Sin 120 degrees is root 3 by 2. 2 sin 120 degrees is root 3. So the polar coordinate r 2 pi by 3 is same as the Cartesian coordinate minus 1 comma root 3. Very simple. Next, let us go for 5 root 2 comma 5 pi by 4. So the corresponding Cartesian coordinates will be 5 root 2 cos 5 pi by 4 and 5 root 2 sin 5 pi by 4. So cos 5 pi by 4 is nothing but cos of pi by 4 is 45 degrees. 5 times 45 degrees is 225 degrees. So cos 225 is nothing but cos of 2 times 90 degrees plus 45 degrees, right? 2 times 90 plus 45. So you have the angle in the third quadrant, so cos is negative, you get a minus. The number is even, so cos remains cos 45 degrees is equal to minus 1 by root 2. Similarly, if you find the same thing for sine 5 by 4, you repeat the same steps, you also get it as minus 1 by root 2. So if you put these numbers here, so you get the Cartesian coordinates as 1 by root 2 and root 2 gets cancelled. So minus 5 comma minus 5. Next, in the third question, you're given the Cartesian coordinates, you're asked to find the polar coordinates. So r is nothing but root of x square plus y square. R is very simple. So r is equal to root of 3 plus 1. It is root 4, which is equal to 2. That is, the point is at a distance of 2 units from origin. Now if you want the angle, so as you can see, minus root 3 comma 1 lies in the second quadrant. First what I do is, I'll find tan theta is equal to modulus of y by x minus 1 by root 3. So when I take modulus, it becomes plus 1 by root 3. So you get 30 degrees. So this is the allied position of the required angle in the first quadrant. That means if I take this angle into the first quadrant, I get 30 degrees. So now what is the corresponding angle of 30 degrees in the second quadrant? Because x negative, y positive, the point lies in the second quadrant. So correspond to 30, what is the angle in the second quadrant? 180 minus 30, which is 150 degrees. That is equal to 2 comma 5 pi by 6. So this will be the corresponding polar coordinate for this Cartesian coordinate. Thank you.